Hi, I'm Neville Atkinson, Senior Inspector of Mines Electrical for Resources Safety and Health Queensland. I'm here today to talk to you about cable trailing management. So I'd like to thank you for your time today, and we'll start from now. I believe that due to the high incident energies involved around trailing cables, these should be treated as a high-risk task. Past performance data highlights some very interesting facts and information. It shows what can happen if you put effort into addressing this situation and where the focus should be. I'll cover more of that later in the presentation. Today I'll be talking about the risks associated with trailing cables, provide some examples of trailing cable incidents and review data from past performance. First up, what is trailing cable damage HPI? These criteria were originally developed to ensure consistency in reporting across all mine sites. Someone sees or hears an arc flash, there is evidence of an arcing event, or copper conductors can be seen. The other one is if the SSE believes it is a HPI. I've had SSEs with a robust reporting and incident investigation culture report incidents where there's been no external damage to cables, but they still believe it should be reported in as a HPI. Risks are typically electric shock or arc blast. This photo is from testing that BMA did at Lane Cove in New South Wales. They put this presentation together for a cable awareness package that they have developed. There's a lot of energy near trailing cable. Typically in open cut mines, these are 6.6, 11 or 22 kV. In an underground coal mine, these are typically 1,000 to 3,300 volts. Remember that the overhead power lines that you see outside your house are typically low voltage 415 volt conductors. Would you touch these conductors? Basically, trailing cables are overhead power lines with a bit of rubber insulation around them. Here's a photo of an incident involving an open cut trailing cable supplying a drag line. As you can see, there appears to be minimal damage to the external parts of the cable. The black line you see is from the energy that was still being released over time after the initial fault. The cable was being moved at the time and was pierced by a sharp object. Typically, electrical protection systems should prevent this from happening. However, sometimes these do and can fail. I can give you some examples of this. At an open cut mine I once worked at, the battery supply to the trip circuit had been accidentally turned off, and the batteries slowly decayed to a point where they could no longer trip the undervoltage coil. The undervoltage coil should have been able to prevent this. However, because of the slow decaying of the voltage, this did not occur. Everything was going fine with this situation. However, we ended up having the centre spindle cable on the drag line rub through, and this caused an earth fault. Because of this earth fault, we then had a phase-to-phase fault. This caused a fire on the drag line and also caused a fire at the transportable substation due to the neutral earthing resistor catching on fire. An underground example I can provide is where I was working at a mine and the deputy came up to me and said that the shuttle car cable had, or the power of the shuttle car had tripped. However, the cable was hissing, which sounded strange. So I went to the gate end box and observed that the power had tripped to the shuttle car, and then the deputy was able to show me where the cable was laying, was laying in water and was in fact hissing. So I went to the gate end box, turned the power off to it, and then when I had a look at what was the cause of this, the vacuum contactor, one of the phases on the vacuum contactor had actually seized in position, which was causing one phase to stay energised. Protection nowadays should have prevented this by tripping an upstream device. However, this does show that these protection systems can and do fail. This is a recent incident at an underground mine where the operators misjudged the corner. A hazard that hadn't been identified was that particular rib bolt was now at the same height as the outrigger of the shuttle car, and this was not to their normal practices. Since around 2016, we've been collecting data specific to cable damage at mines. In 2018, we split this into two categories. Mechanical insult, which is where the cable is damaged due to external sources and events, and the other one is with electrical failure. I'm not going to go into the detail of the electrical failures during this presentation because they form about 2% of those cable damages over this period. In the last 3 years, of the 310 electrical HPIs we've had with trailing cables, only 6 of these were electrical failures. The data I've reviewed for this presentation is of the last 3 financial years. There have been 304 trailing cable damages due to mechanical insult over this period. 169 at surface mines and 135 at the underground mines. As you can see by the data, it has been pretty consistent over the last 3 years in regards to percentage of damage between surface and underground operations. A good thing is in the last financial year, we've seen a decrease by 19 events overall from the previous year, with this being shared between surface with 9 less and underground with 10 less. Why this drop? In relation to the underground, one mine has stopped place change operations during this period and has seen a drop of 8 cable damages due to this. And one large coal mine has dropped from 10 to 4. I'll discuss further later in the presentation how they achieve this. Getting back to surface mines specifically, when do you think these incidents occur? Do they occur at day or do they occur at night? Where should you be concentrating your resources? Well, 105 of the 169 incidents occurred between the hours of 6 a.m. and 6 p.m. Each mine is different and should look at their own data specifically. I know one large surface mine that has had 14 cable damage HPIs over the last 3 years, but all but 2 of these occurred during the hours of daylight. That's nearly 88% occurring at these hours at that mine. Where should they be concentrating their resources? I know that some mines are looking at illuminated trailing cables, which is a good idea. However, I'd still be looking at the data at these mines to see if they are going to get the improvement that they are after with these changes. Again, as you can see, the underground data has been pretty consistent in comparison with surface operations over the last 3 years. How do they compare with surface mines in relation to what time of day or night that these occur? Well, 63 of 135 occurred between the hours of 6 a.m. and 6 p.m. This is more the ratio I was expecting, taking into account possible fatigue and less supervision on these shifts. This is the data from the last financial year for surface operations. As you can see, 66% involved interaction around drag lines and 34% around shovels. I've listed the most typical causal factors. We've got operators not dropping off cable loops, cable tractors putting stress on plugs. Cable tractors do get a jersey in both shovel and dragline operations. We've seen a number of incidents involving the implements of these cable tractors. One of my favourites is the Curtis Jensen operation of deliberately swinging a loaded bucket over a cable and hoping that the rock that falls out hits the mechanical protection that's been put in place. These do cause a number of incidents. Rock drains being too small is also common on draglines. And shovels, again, it's normally around poor pinata operation or cable management around that area. Obviously, individual sites should look at their own data to see whether damages are occurring and whether or not issues around draglines or shovels should be investigated as priorities. As you can see, shuttle cars form the highest amount of cable damage, with 63% of underground trailing cable HPIs last financial year, with operators misjudging turns, inadequate or poor protection of cables on the rib, poor roadway conditions causing build-up of coal and debris in the reelers. And another favourite of mine is backspooling. And the normal excuse of why it occurred is that the operator was not paying attention at the time. I've got a simple solution to this: don't backspool. Continuous miners come next with 18%, and this is normally around damage or poor handling around the machine at the time. Longwall last year only had 3 reported incidents. The interactions around mobile boot ends, we had 1 as well. These next 3 slides are the figures involving a mechanical insult between place change operations versus longwall only operations. One of the mines listed isn't currently a longwall operation. However, they are setting up to be one and are not setting up to be a longwall place change operation. So for financial year 2021, we had 13 incidents involving place change, with 8 being the highest at the longwall operations. One of these listed as a place change operation was also conducting longwall operations at the time. So for financial year 1920, we had 10 and 8 before we get to the highest of 6 at the longwall operations. So as you can see by the data, place change operations regularly outdo their longwall only operations insofar as cable damage being reported. For financial year 18-19, we had 10 and 8 before we get to the highest of 7 at the longwall operations. The difference between place change versus longwall would be expected, given the interactions, or the extra interactions that you have at place change and movement around these activities. Also, you can see that some longwall operations do far better than some of their other counterparts in regards to this type of damage. These are the things to look for at your mine. Are procedures up to date and easy to understand? Is there accountability and ownership? Are all incidents thoroughly investigated? Or are they just put down to operator error and we just move on and forget about it? What critical controls failed or were missing? Are the incident investigation recommendations being implemented? Are they sustainable and are they being followed through with? If you're having repeat incidents, are you questioning why this is occurring? Are coal mine workers finding, fixing and reporting incidents? What is a reporting culture like at your site? Do you try and find reasons not to report an incident, or do you actively go out looking for these as high potential incidents? The surface mine I spoke about earlier, this is mine A in this example, they reduced their cable damage HPIs from 10 to 4. I spoke with the mine to find out how they achieved this, and basically the reason they gave me was luck. They've had a number of cable damages at the mine that weren't deemed to be high potential, and they are still having a lot of cable damages. They do realise it's an issue and they are working towards fixing this. This time I've looked at performance over the last 5 financial years. This one's not luck. At another large surface mine, they had 23 cable damage HPIs in financial year 16-17. They did get a visit from the inspectorate to talk to them about what they're going to do to manage this, and they did raise the focus on trailing cable damage. They looked at the management, they put ownership and responsibility back on the troops, and they also improved their cable management practices and procedures. And one other thing they did was redesign how they set the pit up to reduce the amount of cable interactions that they were having. And as you can see, they dropped to 8 the next year, and this financial year, the most recent one, they only had 3, so they've been improving every year. So, at the end of the day, don't drop the ball. Look at the data and find where the issues are and act accordingly. I'm assuming that for every HPI reported, there will be a number of incidents that do occur that weren't HPIs. If you look at these in detail and investigate them, you may be able to decrease your overall cable damage. As you've seen by the data I've presented today, you may be focusing on the wrong areas. You need to look at what your figures are and what is happening. Make people responsible for their actions. Give the troops ownership of cables. Have robust cable management procedures that make people comfortable and accountable. If in doubt, report and investigate the incident. I'd rather see an increase in cable damaged numbers if that increase is driven by SSC's reporting cable damages that don't fall under the strict criteria of arc flash or copper conductors being seen, but about incidents that they also perceive to be HPIs. This would demonstrate one of the attributes of a high reliability organisation. Treat trailing cable management and operation seriously. These are high powered, high voltage conductors with only a small amount of insulation between you and the power source. Thanks for watching this presentation today. My details are on the screen. If you want to talk to me further or contact me via email, please do so. Again, thank you.